So, some things. Charles, go around. Where's your sidekick? Where's your sidekick?
He's upstairs.
Y'all usually stroll in. Okay, so exit card yesterday, not spectacular. I highly recommend that you guys find some time at lunch today or tomorrow or Thursday to come in for help. Tuesday and Thursday, so today's a Tuesday, Math Honor Society, C215, Mr. Melendez's room. I checked yesterday, the vice president was in my class now, the president was in my class last year. I'm like, our kid's coming. They're like, that's you. There's like 20 helpers there. Y'all need to go, okay? You need to go and ask questions and get one-on-one help. They're good with logs, they can help you. Wednesday, you can come here, I'll be here and try to get more helpers. Because that is on the quiz Friday. It was largely Algebra 2. A little bit of pre-cal in it, but it's an Algebra 2 concept that's old, so we reviewed. And I've noticed, so I did all the Delta Math homework. There were things I didn't intend, but they were on the homework, so you guys should have been able to fight through it. I could see some issues, like where there's legitimate, okay, that was gross, that was a yucky question or something. But I can also tell that people are using, we'll call it AI, to do the homework just to get the homework credit, but that means you're going to fail the quiz. So if you guys don't try the problems yourselves, it's like the homework isn't there just to be busy work. It's meant to give you the practice so you'll be familiar with the quiz itself, and that the quiz or the exit card itself was on Delta Math. Maybe doing the Delta Math legitimately would have helped you. So there's that as an issue. But here's the good news part of it. Friday's quiz, the portion of it that is a repeat of the exit card stuff, that will be the retake. If you would like the average from those questions to replace your average from the exit card, we'll ask you to check a box and we'll swap it out. Okay, so that is the retake. Spencer?
Are the grades for the exit card in?
They're in. They were in yesterday at lunch. Yeah.
Wait, do we get to see our scores before we check the box, or if we check it?
You should. They're up now. Like they're in.
No, like on our quiz. Like if we check it and we get a lower score instead of.
I won't replace, like, if you got 100 on the quiz, on the exit card, which some people did, and then you just fritz out on the quiz itself and get a 50% on that section, I'm not gonna take the points away from you from before. No. But yes.
Sorry, I didn't hear how the retakes work for the exit card.
So, okay, in general, each quarter, at the end of the quarter, you can retake one exit card and one quiz. This exit card was hands down not great. So, like last semester, we let you guys do a retake on one of the quizzes, like immediately. We let you do quiz corrections. So this one, a lot of people did poorly, so we are letting the quiz on Friday that is on graphing, as well as the stuff that was on yesterday's exit card, possibly more like log, using the log rules. The average on that portion of the quiz can replace your exit card score. So if you got 9 out of 10 right on the quiz for these kinds of the questions like the exit card, you'll have a 90% on the exit card. Okay? Any other questions about the deal? Yeah?
Sure, one more question.
Not exactly. I'm gonna ask, like, so, the homework last night, I wanted you guys to try the rest of that circuit worksheet, but I didn't officially assign it because you guys looked a little defeated, so. But today we're gonna do graphing, and I have a worksheet, but I want you guys to have this one in your notebook first. So, this is an exponential, not a log. Jean Gideon, putting in these x values. 2 to the x, what is 2 to the, 2 to the 1?
2.
2. Allie, 2 to the 2. Emmy, 2 to the 3. Jonathan, 2 to the 0. Jonathan, 2 to the 0. Don't know? Oh, 1. Charles, 2 to the negative 1. 1/2. Okay, so let's graph those coordinates. 1, 2, 2, 4, 3, 8's not going to fit on here. 0, 1, and negative 1/2. Whoever's still playing their music, can you turn it off? Okay, that's fun. Okay, domain. What are all the x values that can go in this function, Bailey? Is there an x value that I'm not allowed to put in the exponent? Does any x that we put in there cause it to divide by 0 or a square root of a negative? So I can put in anything.
Yeah.
Okay, so the domain's all the numbers that ever could have been numbers, negative infinity to infinity. Mayuna, looking at it, what's the range?
0 to infinity.
Square bracket, round bracket, mix and match,
Round.
both round. You never get to 0, so round. Okay, Nate, right end behavior.
X towards or f of x equals infinity.
Kevin, looking at it, left end behavior.
As negative infinity.
As x goes to negative infinity,
0.
y goes to 0. Okay, cool. Well, the point of this is we want to go in reverse. We want to find the inverse. Arden, do you remember what the inverse function of exponent is? No? Chloe? Hint, hint. It's the log. If I want to undo exponent, I'm going to do log. And these are like wildly useful. If you want to know, hey, I want to triple my investment in a year, what's the rate that I need to get to make sure that I have 3 times my money by the end of it? That requires a log function. Yeah.
Are you giving me word problems on the quiz?
The quiz, no. The quiz after this, like after Thanksgiving break, we're gonna do harder log problems, and they do involve word problems. So I was just introducing one now, didn't mean to scare you about Friday. Yeah?
Will the district assessment be on logs too?
Yes. District assessment is largely logs, and the district assessment is a semester thing. I don't know how that, like, I think it's mostly on logs, but it's allowed to be on stuff from first semester. Okay, all right, so 2 to the x. Naomi, if I was to change this from exponent to log form, what does it look like? How would I rewrite it? Well, sorry, that's a 2. My bad. Okay, okay. What I was looking for was that. So she said inverse, inverse. I'm going to trade the x and the y. Yes, and then getting things apart. Changing from exponent to log form. Log base 2 of y equals x. So my inverse is going to be that. Spencer, inverses, we trade the x and the y. So how do I fill out this table given this one?
Like 2, 4, 8.
So 2, the x and the y trade.
Oh,
So 2, 1.
And then 4, 2, 8, 3, 1, 0, negative, or 1, negative.
Okay, so just trading x and y, because they're inverses. So now let's plot those coordinates. 2, 1, 4, 2, 8, 3, 1, 0, 1 half, negative 1. Tim, what's the domain of my purple function, the log?
0 to infinity.
Round brackets or square brackets?
Round.
Round. What's my range, Joaquin? What are all the y values that come out of this purple one? So where does it appear to start? Where do the y values?
Infinity to positive infinity.
Yep. Inverses? Usually, x and y trade. Ins and outs swap. The domain of this one became the range of that one. The range of this one became the other guy's domain. There it is. Okay. All right. So, can anyone tell me what's the asymptote of the pink exponential function? Or does it not have an asymptote? Holiday, what do you think? Y equals 0. Okay. When we did rational functions, those were polynomials over polynomials, x's with just x's. Log and exponential are no longer polynomials. So the end behavior on the left and the right, they're now different. But as I said, inverses, the x and y's trade, this exponential had a y equals 0. The log function is going to have a vertical asymptote at x equals 0. Cool? And all those graphs, they fold over y equals x. Okay, can you guys write these in notes? If you're writing on a whiteboard, can you get notes out and write this in your notes? Things that will be true for every single log function that is not shifted. Basically, it's a parent function. So anything that's of that form, log base b of x, is going to have those things true. So if you know what the parent function of a log looks like, that will make the rest of this graphing unit easy, I hope. Jean Gideon, b is some number, like 5. What's b to the 0?
1.
So when we put in 0, we got out 1. Leah, when I say b to the first, what do I get out? 5 to the first, what's, okay. 5 to the first is 5, 7 to the first is 7. She said, b, yeah. So on an exponential, every single, whatever to the 0, except 0 to the 0, whatever to the 0 is going to be 1. So on an exponential, the coordinate 0, 1's always on there, so its inverse is always going to have 1, 0. And then whatever base you like. Dylan, your favorite number is, I don't know, 7. So if I said 7 to the first, 1, 7, that would be 7, 1 is going to be on the log function. And the exponentials are always going to look like that and have a horizontal of y equals 0, so the log is always going to have an x equals 0. Okay, can we look at the first function on your sheet? And it has a grid on there already, good. Yes, do you guys not? Skipped, so sorry. Ah. Okay, first off, I want to find where the vertical asymptote is. The vertical asymptote is going to be whenever the stuff in there is 0. Okay? Well, when is x 0? At x equals 0. So I'm going to put in my vertical asymptote. And then I said there'd always be 2 specific functions on, or coordinates that will be on this curve. Does anybody remember one of them?
1, 0.
1, 0. So graph we're going to graph the 2 known points. One of them is 1, 0. So go over 1, 0. What's the other coordinate?
Base 1,
Base 1. What is the base in this question?
3.
3. So we're going to plot the coordinate 3, 1. 1, 2, 3, 1. And then I'm going to just, with 2 coordinates and the asymptote, I kind of know what it looks like. There it is graphed. I'm asking more information about it, but there's the graph. How you guys doing with that? Bailey's like, I don't know.
Oh, that makes sense.
Okay. Yeah.
Does it only need 2 points on it?
So with logs, it's really hard to get 3 points that are nice to fit on it. So I need those 2 points at least, and the asymptote, and then I'm okay. Like if your graph does what it's supposed to do. Okay. Then I can ask things like domain. So Cameron, looking at the red graph, what's the domain?
0 to 8.
Okay, yeah, so domain is going to pick up immediately on the other side of that vertical asymptote. So if you didn't know where it's coming from, vertical asymptote's at 0, so everything bigger. What's the range?
Negative infinity from
All the numbers that ever thought they could be numbers. Okay, x-intercept. Natalie, x-intercept is when who is 0?
y.
When y is 0. All right. So this is going to get trickier for some of the other ones. So I have log base 3 of x equals 0. All right. Jasper, do you know how to switch this from log form to exponential? Base to the power equals the argument. 3 to this. 3 to 0. So
So 3 to 0 equals x.
3 to the 0 equals x. What's 3 to the 0? 1. Okay. So the x-intercept is when y equals 0. So I made y equals 0. And Jasper translated it from log form to exponent form. Boaz evaluated 3 to the 0 to say it's 1. So go figure, we just got the x-intercept, which we knew in the first place because Jean Gideon said it from the beginning. Thank you. There it is, 1, 0, just confirmed. All right. I'm also asking here to find the y-intercept. Looking at my graph, there's an issue. Y-intercept is when x is equal to 0. When is log 0? John? When is log 0? So if it was an exponential, that's 3 to the y equals x. Remember, our domain is bigger than 0. So this one, does it look like it's ever going to hit the y-axis? It gets really, 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 really close, but it never hits it. So this one, when I'm trying to do log of 0 or log of something negative, no, dead to me, cannot happen, can't do it. Okay, and we have our asymptote there, it's graphed. Yay. Kevin, what's the second question?
Y equals log 3 parentheses x plus 1. So we're gonna have the graph go on left 1, and it's gonna have yeah, it's just gonna be on the quadrants 1 and 3.
Okay, so first thing he said was, because I know what transformations do, that's going to move to the left one. Why does he know that it moves left?
Is that x plus 1?
Because take that inside stuff, set it to 0, it moved. It moved. Okay. So here's how I graph these. All right. So from my pretend new axis, I didn't move up or down at all. My new origin is my fake origin. It's not really the origin. The origin is where the blue lines cross. But from here, so Joaquin, you ready for the trick? From my new thing, I'm going to plot the 2 coordinates that I plotted over here. So for my new fake origin, I'm going to go over to 1, 0, and as Emmy said earlier, base comma 1. Samara, could you see that at all? So, new properties. All right. Vertical asymptote is where that inside thing equals 0. Don't tell me -1, it's x equals -1. I need the vertical line. Domain. Is the domain exactly the same or did it change? Range is exactly the same, but the domain did change. What is the domain going to be? -1 to 0, round brackets. Is this making any sense? What else did we ask? X-intercept and y-intercept. Looking at the graph, I can see it. Alicia, what's the x-intercept? When x is 0. So when x is 0, log base 3 of 1, 3 to what power is 1? So. The y-intercept, putting in x is 0, I got out y is 0, and I could have solved the other way, whatever. The x-intercept, y-intercept, it's the same thing, it's the origin. Okay. So this is how I teach graphing, is you need to be able to find a vertical asymptote and base comma 1 and 1 comma 0. Okay, can you guys try the one on the back with your group? And I will come by and make sure that you are on target. Yes, Natalie.
What is REB?
REB, right and behavior. So sorry for our weird acronym. We need to move two things. She did already for this one. Okay, so I find it really hard to do this without moving my axes around. So the x-axis is going to move where? 2 down. Why? Because y got shifted down. It's not an asymptote, it's just a line that's helpful. And then the vertical axis moved where? 3
Down.
to the positive. So x equals 3. So that's our new origin. So from there, we're going to plot the two coordinates, 1, 0, and base comma 1. X-intercept is when y is 0. So setting y to 0, we need to go through the process and solve from there. Okay? Yeah? So as looking, people seem to be getting started well, and let me do this.
For x-intercept, that's
Yeah, if you're to put in
So
physically cannot get 3 to any exponent to equal -3.
So first of all, are you guys okay with this piece? I didn't do both shifts in an example yet. So, table 1 said that -2 kind of pretends to move the whole x-axis down 2. And this x minus 3, that's basically kind of pushing the y-axis to the right 3. So from this fake moved origin, I'm going to plot which two coordinates, Bailey?
I was kind of confused because I didn't know if you did 1 to 0.
So, yeah, the coordinate 1, 0 from my fake, like not the real 1, 0, but from my moved spot, I'm gonna plot the coordinate 1, 0, which is not 1, 0, but we'll just leave it like that. And what, Dylan, what's the other coordinate that I wanted?
Would it be the x-intercept?
No, that one's hard to, that's what I want to get to answer what people are asking is how do we find that? What's the other coordinate?
3, 1.
Base, comma 1. So from the fake origin, the base here is what?
3.
3. So from the fake origin, move over 1, 2, 3, up 1.
1 to the 0 minus 2.
So there's my graph. And people were asking about the x and y intercepts. Which one should I do first? X intercept? Okay. To find the x-intercept, and I will ask you to do this on the quiz, to show me, like, there will be a box on the paper that says, show me that you are calculating the x-intercept. Where does the function hit the x-axis is when y equals 0. So I'm going to pick the whole function up and say, this equals 0. And now I need to solve for x one step at a time. What is the first step? To getting x all alone. How do I get x out of there? Well, I did set it to 0. I'm going to get rid of that minus 2 by adding it to both sides. Now there's stuff in the parentheses, in jail, in the log. I need to convert from log to exponential. How?
Make the base
Base to the, so 3 to the,
3 minus, 3 2.
3 to the 2 equals,
the argument.
equals the argument, equals that stuff. Yes?
It's x minus 3.
It's x minus 3. I copied it wrong, so sorry.
Yeah.
Sorry. So x minus 3. X minus 3. Thank you. Okay. Sorry. So, algebra. What's 3 squared?
9.
And then add 3 to both sides. So x is 12. As a coordinate, where it hits is 12 comma 0. So x-intercept, 12, 0. Question? Yes?
I don't understand what the
It's just the x-axis. I'm pushing it to where it got fake moved. It's not an asymptote at all, but it's a reference point for me to be like, yeah, it's just a reference. It's not an asymptote though. Yeah?
So when you had to log base 3, you just took 3 over it and made it 3 to the...
Okay. So here, this was stuff that we had on the exit card yesterday and that we evidently need a lot more practice on is changing from log, oh, come on, log to exponential. Spencer?
Why couldn't you just set it equal to like 3 to the 0 equals x minus 3 and then minus 2?
Because, all right, I can't do 3 to the 0 yet, because I gotta do that operation to both sides. And if you're not doing it with the negative 2 involved, that's,
But can't you just do it later?
no, needs to be done now. Like, okay. Can I say, well, if it's 0 equals square root of a minus b, can I square just this and then move the b? No. So log has that same issue, you gotta do it to the entire side. Okay. That's finding the x-intercept. To find the y-intercept, which graphically looking at it, what's our y-intercept? We don't have one. So y-intercept is when x is 0. That one's easier to do. Log base 3 of -3 minus 2. Can't do log of a negative. Can't do log of 0, can't do log of a negative. I don't have a y-intercept. Good? Yes?
So does the negative
It's not multiplying, it's subtracting 2. Okay? Okay, try the last one that's on the sheet. Oh, sorry. So the graph was somewhere down here. Left end behavior. As x goes to super duper negative infinity, I don't have a left end. Straight up, it's not there. Right end behavior, very, very slowly. It's got its little walker out, it's trying. It will get to infinity eventually. Okay, try the last graph.
Yeah, I just rewrote it. Rewrote it. And put the 5 in that.
Okay, so Spencer and Neil will find like how to start.
Yeah. We'll start with like -3. And then yeah, like those steps. So like the new words kind of going to be -3, 4. -3, 5. Right, yeah.
In parentheses, that's the
So you go
just outside of the parentheses. And so I did write it differently on purpose.
Wait, can you explain how you got this one? The purple line is right.
But if you move plus 5 over here, so it's that it bothers you guys and different contexts, sometimes it's gonna be well, it's 5 plus this crap. Plus 5 plus 5, and y'all got it.
You get 6 ones over there.
And we don't get a pretty number on these, and you can leave it as something gross. The worksheet I just gave you is practice to fix things up for the other part of stuff that was on the exit card yesterday and that will be on the quiz, and that you can take that to extra help at Math Honor Society, and there's the little math extra help passport things in the back. If you want to get somebody to sign off on it on 5 visits, you get a free homework pass. Yes, ma'am.
Which one is this homework?
Okay, well, you just finished
But you don't start at the
almost
words,
the
you
graph
start
of
at
this,
the
so finish the last
zero.
graph, and the homework is the sheet that I just handed out.
So, I'm confused with the 5 is. Does it just
Sorry,
put it-
what?
The 5.
Oh,
does it just
okay.
put it up 5?
Guys, as someone else just asked, that one had a -2, that one has a 5. The 5, it's just in a place that you're not used to, but if you need to, you can move it. It's just a vertical shift. Cameron?
Wait, are people also doing the,
Spencer?
For like, do you start at the word like 0, 0, or do you start at 1, 0?
Okay, so I'm gonna first move my axes. There's my real spot. But I'm gonna pretend, I'm gonna move 1, 2, 3, 4, 5 up
Yeah.
and 4 back. 1, 2, 3, 4.
From the origin, I thought it was from 1 to 0.
Okay, no. So I'm moving these axes, this one, x minus 4, different color. X minus 4 is my new, that one, and up 5. So from this new fake origin, I'm gonna plot the coordinate 1, 0, and base, comma 1. Okay, the x and y intercept, I have them, and they're yucky numbers. Which one should I do first? X intercept, okay. So when y is 0, and keep the parentheses. Some of you, 2 of you, Kevin, got a point off on the delta math yesterday because you didn't do parentheses. Which is stupid, but they were not wrong, the way it was written. So be careful, the parentheses are needed. So solving here. Now I'm stuck. I need to convert. Alicia, how do I convert this log to exponential? Okay, and I don't expect you to know 3 to the 5. But, so as your intercept, gross, that's what it is. Y-intercept. Y-intercept is when x is 0. So when x is 0, I don't know what that is, so I'm going to leave it. Hang on 1 second. If this was base 4, log base 4 of 4, that one I expect you to know is 1, and you would evaluate it. Log base of 3 of 4, I don't know. 1 point a little bit. Tessa, what was your question?
How would I know whether it's okay to leave it as like 3 to the negative 5 versus x solve?
Well, if you really need a calculator to do 3 times 3 times 3 times 3 times 3, like that's a lot. It should stand out as like, can I evaluate that without a calculator? Is 3 to some power equal to 4? No, you're just done. Okay, so guys, do the circuit training worksheet. Go to extra help.